Okay, recording started. Okay, welcome back to week 4 Art Studio workshops. Today we are continuing learning how to make statistical graphs using Art Studio, specifically using the ggplot2 package. We did learn something about this package last week. Last week we learned how to plot. What did we learn last week? Last week, how to plot box plots. Not just one box plot, but a series of box plots in one graph. Okay, you can compare the distribution of the numerical variable across groups, right? You can plot multiple boxes in one graph. We also learned how to plot multiple histograms, overlay them on one graph, okay, for the same purpose of comparing the distribution of a numerical variable across groups, right? And then we learn how to plot density plots, which is kind of a modern version of histogram. Okay, and in the end, also introduce something called violin plots, which is combination of box plots of density plots. If you missed that, just catch up the workshops last Thursday. Today we continue. Again, log attendance when you have time. I will email you the link to attendance feedback and then download and recording this afternoon. You should have already received my email about a copy of the slides. Okay, just have a copy. ggplot2, we continue using this package. As mentioned last week, ggplot2, GG represents grammar of graphics. There's a book about this GG thing, 2 versions, 2 editions, and also there's an open book called ggplot2. There's a link in the slide. It's open book, that means it's free to read if you want to read. Okay, and then just remember one thing for the moment: ggplot or grammar of graphics organize things or elements in a visualization by overlay the layers. Okay, you have layers of data, ethics, geometries, blah blah blah. So we put them in layers. Okay. So today's agenda. Today we talk about how to how to visualize the relationship between either 2 numerical variables or 2 categorical variables. When we are interested in the relationship between 2 numerical variables, I think the first plot you should think about is the scatter plot or XY plot. Okay, it's probably one of the most important visual tool in data science or statistics. And if you have 2 categorical variables and you want to investigate their relationship, and the first plot you should think of is the bar chart. Okay, bar chart. All right, so first one. We will use the same data as we did last week. It's called Gapminder. It's a longitudinal data set of the variables of population, GDP per capita, life expectancy of 142 countries from 1952 to 2007. Okay, we record their values of those variables every 5 years. So basically, there are 12 observations per country, right? And then the same country, 5 years later, another observation. So in this time period, every country has 12 observations of those 3 variables. Okay, so if you haven't installed the package, please install the package. You have already installed it, just library it out. And then we can create a copy of the data set, we'll call GM. And you have a quick summary of the data set. You can run the function summary GM. Okay, so this data set, and then the We also need 2 more packages to do the job today. The first one, of course, is the ggplot2. Elaborate it out. And the second one is tidyverse. Okay, we have used tidyverse quite a few times this semester. Right, and then as I mentioned last time, R has a series of base functions of making graphs, statistical graphs. That are not too bad, but we will focus on ggplot2 because ggplot2 give you more control of designing data visualization. Again, if you have any error like this, error in the plot view, figure margins too large, that means your bottom right corner of your RStudio is too small. Make it a bit larger. Okay. So that's my RStudio. So if this corner, bottom right corner is too small, sometimes when you request a random code to create a graph, you will get this message. This red words, margin too large. That means you have to make the bottom right corner a little bit wider and higher. Okay, give it enough space and then run the code again. Hopefully the graph will show up. Okay, all right. Okay, again, we will work on the examples. The first one is just a basic scatter plot. Now the 2 variables we are interested in are GDP per capita and life expectancy. Okay, let me load the stuff I need to use today. So first of all, I will run this bunch. Open a new file, open a new R script file. Okay, Control V. So I will library out. You can highlight the line and then click run, or you can put the cursor at the end of the line and then press Control Enter, or you can put the cursor at the beginning of the line and then press run. So this single line will be run. Okay, and then I will create a copy of the data frame. And copy is called the GM. Okay, I don't want to summarize it. Just double click the object. I can view the data. As I mentioned, every country has 12 observations every 5 years on those 3 variables: life expectancy, population, and the GDP per capita. So what I'm interested in is the relationship between GDP per capita and the life expectancy. See, I want to see how they change together. Okay, how they co-vary in statistical language. Okay, if one variable increases, how about the other variable change? Okay, if one variable decreases, how about the other variable? Okay. The data is called Getminder. You have to install this package. If you haven't, you have to install it first. So it's on my slide, page 5 here. Okay, yeah. So download a copy of the slides and then just follow through. Okay, thanks. All right, now how do I create the scatter plot? No worries. Yes. Next page. So first of all, I will just choose some observations because I know well, let me run this one first. Okay, so Control C, go to my RStudio copy. So you see, I'm using the tidyverse language. So my data set GM, you can call it whatever you like for your copy of the data frame. And then that's the pipe operator in tidyverse. And then I'm choosing the rows where the GDP per capita is less than $50,000 per person per year. Okay, and then I use ggplot, and the x-axis is GDP per capita, the y-axis is life expectancy. So be careful, all the variable names have to be exactly the same as the variable names in the data frame. Okay, and then the R language syntax is case sensitive. So lowercase, uppercase, they are different things. Okay. Remember grammar of graphics, organize things by layers. So my face layer, I set up the horizontal and the vertical axis, X and Y axis, and then second layer, a plus symbol. I nominate the geometry. So I'm using the points to represent the data. Okay. So if I run this block of code, I should get my graph. Fingers crossed. Couldn't find function this one. Why? Because I haven't loaded the ggplot and the tidyverse packages. All right, so go back on my previous page. I have to load these two packages. Okay, I haven't loaded them. Control C. All right, I need to library ggplot2. It will take a few seconds because ggplot2 is large. And then also library tidyverse. Okay, now I have run my graph. Okay. Run the codes for my graph. Oh, what's the message? Oh no, I'm raising my transcript. What's the question? Yeah. I didn't share my screen. Kidding me. Yeah, thanks for the reminder. Yeah, so if I miss something, just yell out. Because yeah, can you see my screen now? For people online? Yes. Yeah. For people online, so if you have any question, just speak out because I don't check the chat box every second. So just yell out. Okay. So I can't see you, I can't hear you, or whatever question you have. Okay. Yeah. So I was recording, but I recorded my audio, but I guess the screen is not recording. Anyway, it's the same as last week. Okay. Today's topic: ggplot2, agenda, 2 important plots, scatter plots, and then bar charts. And the data is the same as we did last week. Okay. And then this first plot. Okay. You can see this is the graph, the XY plot or scatter plot. So I put the GDP per capita on the horizontal axis, and then put a Y on the. I put a life expectancy on the Y axis, because I'm interested in how the life expectancy changes as GDP per capita changes. Or I'm hypothesizing that the level of wealth may impact the level of health. Okay, so I'm using the GDP per capita as an indicator of level of wealth. I'm using the life expectancy as an indicator of or proxy of level of population health. Okay, so if your research question has like a very specific hypothesis about the dependent variable and the independent variable. In other words, the variable that is the factor or cause, we call them independent variable. And the variable that is the outcome or response, we call them the dependent variable. So if your research question has this kind of a clear hypothesis about the independent variable and the dependent variable, we normally put the independent variable as the x variable in the horizontal axis, and then we put a dependent variable, or outcome variable, or a response variable on the y-axis. Okay, just the convention. Yeah, all right. Yeah. Dependent variable is the variable you think that is affected by something else. That is the response to some cause or factor. Okay, we call this dependent variable. And then the factor, the cause, the predictor, we call them independent variables. Okay, yeah. Predictor, cause, factor, they don't mean exactly the same thing. Okay, we can talk about them in future if we have a chance. Okay. So in this case, okay, any question online? Okay, thank you. Yeah. So in this case, you can see that when you describe a scatter plot, you have to describe a few things. First of all, if there's any non-random pattern in these points of data, okay, each point is represent an observation. Okay, is representing one country's level of GDP capacity, GDP per capita, and life expectancy in a specific year. Right. So look at these points on this scatter plot. Can you see some non-random pattern? Obviously, there is. If there's a random, you just see a random ball of points. That means there's no relationship between these two variables. Okay. As long as there's non-random pattern, as long as the graph doesn't show a random ball or cluster of points, that means there must be some relationship between these two variables. Okay. And I have to describe the shape of the relationship. Okay. In this case, it's kind of a, you know, kind of increasing trend, right? Yeah. Oh, we talk about that later. Very soon. Yeah, yeah. So you can see that it's kind of a increasing trending. So as the x variable increases, generally speaking, the y variable tends to increase. Okay, but the increase is not very always the same. So initially it's increasing very fast, like from 0 to like 10,000. So as the GDP increases, the life expectancy quickly increases. Okay, but after like $10,000, it starts to plateau or level off. Okay, yeah. So this kind of increasing trend, we call this positive relationship. Okay, positive relationship. That means the two variables tend to increase or decrease together. So as one increases, the other one also tends to increase. Not always, but tends to. Okay. If you jump from one point to the other point randomly on this graph, if x value increases, normally speaking, the y value also increase, but not always. Okay. If you jump from this point to this point, x increases, but the y decreases. But if you look at all the possible jumps between 2 points on this graph, generally speaking, if you increase x value, or if x value increases, y value also tends to increase. Or if x value decreases, y value also tends to decrease. Not always, okay? Not always. So that's the shape of the relationship. It's kind of a positive relationship. And then that's the direction of the relationship, okay? It's a positive. And then the shape is not linear, okay? That means the rate of change is not always the same. Initially it's fast and then slow down. Okay. Okay. And the strength of relationship in this case is probably it's not too strong, but not too weak either. So what do I mean? A strong relationship? If the relationship is strong or perfect, that means all the points are standing on the line. Okay. If the relationship is weak, that means the points are scattered around the line. So this one, the points are not standing on the line perfectly, but not scattered everywhere. So it's probably moderate or medium to positive. So medium to strong. Okay. Yeah. So if the relationship is perfect, that means there's no exception. Okay. All the points are standing on the trend line, and then if x increases, y always increases, or vice versa. But in this case, you see the points are scattered or dispersed around the trend line. That means there are some exceptions. As I mentioned before, from this point to this point, x increases, y decreases. But generally speaking, if you move from any 2 points on the line, if x increases, y also tends to increase. Okay. Why did I just choose the filter? Why did I just choose the entries that are not super rich? I just want to show this graph. If I remove this line, we can get a new graph. If I remove this, if I comment it out, hashtag. Okay, let's get a look at the whole data set. You can see that if I didn't remove any super rich countries in those years, we have a few more extra points. So again, depends on your scope of study. If you want to include everyone in the study, you also have to mention those guys in your description of the graph. So generally, this trend is a positive, but non-linear, initially fast and then level off or plateau, and the strength is a kind of a moderate to strong. However, there are a few outlying cases or outliers. They are lying out of the bulk. Okay, so they are kind of super rich countries, but their life expectancy is kind of a more medium to high level, but not super long, right? Not super high. Okay, if it's not following the trend, because if these countries are following the trend, we should expect them to have a life expectancy maybe 120 years old for everyone, okay, on average, but they are not. They're super rich, but their life expectancy is kind of just average level, 60 something years old. Okay, yeah. Well, you are the analyst or you're the researcher. You have control of your story. Okay, your scope of your story, your interpretation of this of your data analysis results. Okay, all right. Okay, so when you have a scatter plot, remember have to first of all spot if there's any non-random pattern. By random, I mean just a random ball of points. That's boring, nothing to comment. That means no relationship. As long as there's non-random pattern, that means there is a relationship between two variables. And then you have to describe the relationship, the direction, positive or negative, okay? The shape, is it linear or non-linear? And then the strength, is it strong, weak, or moderate? Okay, yeah. Strength means how closely the points standing on the trend line. Okay, it's not about the slope or the steepness of the line. That's not about the strength. Okay, the strength is about how closely the points are standing along the trend line. The trend line. Okay, yeah. So this is a kind of a simple relationship. It's not super complicated. Okay, so it's easy to describe. All right. So the direction, the shape, and then the strengths. All right, we can modify our plot as we did last week. We can color the data by continents. Okay. and then we can size the points by population, and then we can the points be more translucent, so we can see the overlapping, the density of the points. Okay, where the points are dense, where are sparse. Okay, let me check if any question from people online. Any questions for people online? Okay. All right, so again, just copy the code and give a go. Proceed. So V again, I'm just investigating the average countries. I mean, I just excluding the super rich ones. Okay, so my threshold is $50,000 per person per year. Okay, average GDP per capita. So again, my data set, I choose the rows I want to keep, and then ggplot the X variable, Y variable, and then a color by continent, and the size by population. Okay, so that's how you change the color. You change the color of points. You can color points by a factor variable, COL, continent, comma, size by the size of the points by population. The population has to be a numerical variable, and then geom point is a point. Geometry is point, and alpha is to control the translucency. If alpha is 0, that means totally transparent. You can't see anything. If alpha is 1, that's by default. That means no translucency. Okay. Yeah. So, all right. Let me run the graph. I hope you got the same. You got the results already. So, run. Yeah, doesn't look too good, but once you make it a bit larger, or you can adjust the ratio and then copy out, it should look better like this. Okay. So you can see the relationship between the GDP per capita and the life expectancy between the X and Y is kind of different in different continent groups. Okay, yeah. The red one is represents African countries. Yellow ones are American countries. Green ones are Asian countries. European are blue, and Oceania countries are kind of purple. Yeah. So now we have how many variables we have on this plot? We have X GDP per capita. We have a Y life expectancy. We have the third variable, which is continent for coloring. The fourth variable is population for sizing the points. Okay. Yeah. All right. I have 4 variables. So scatter plot can be used to visualize information more than 2 variables, not just X and Y. Okay. Yeah. Alpha is to control the translucency of the geometry. Yeah. If it's 0, it's totally transparent. If it's 1, it's not transparent. It's a solid. Yeah. Yeah, yeah. You can try different alpha values, see which one you like. All right, we'll continue. Now, sometimes you may want to find a linear relationship for some reason. For example, your PSD1. Actually, if you have a chat of PSD1, there's a similar question. Okay, so we can transform variables, either one variable or both variables, X and Y, to see we can obtain a linear relationship. So why do we want to get a linear relationship? First reason, I mean, a very straightforward reason I can think of is that linear relationship is easy to describe, right? And also easy to quantify, all right? Because in week 8, week 9, or week 10, you will learn linear regression. And the first one is simple linear regression, basically a statistical model describe to quantify the linear relationship between X variable and Y variable. Right? Yeah. Sometimes we want to obtain a linear relationship between two numerical variables. And then one reason is that linear relationship is easy to investigate. All right. And the most commonly used tool is simple linear regression, which we will learn very soon. Okay. So what I did, what did I do? I take a logarithm transformation of the X variable in this case, as you can see in my code here. So instead of writing X equal to GDP per capita, I wrote X equal to LOG. Remember the operators of R I talked about in the second week, maybe. There are a bunch of math operators in R. LOG represents the natural logarithm. Yeah, so LOG means the natural logarithm. The logarithm of the variable GDP per capita using the constant of E as the base. Yeah, remember E as the mathematical constant, E. And then didn't do anything about with Y, life expectancy. I just leave it there. So I just took a logarithm of the X. And then I plot the data again. And also I added one more geometry. It's called a geometry smooth trend line. Okay, geometry smooth. Okay, I got this graph. We can give a try. Hopefully we get the same thing. I got some warning, I just ignore it. Yeah, and then if I enlarge this graph, it should look like this. Yeah. So now we can kind of the log transformation kind of unfold the squash the x-axis. Remember the previous one like this. The y-axis kind of squashed. And then after taking logarithm, kind of unfolded the y horizontal axis. So I can see more details of the data, the changes. Okay. Remember log transformation? If the values are 1, 4, 9, 16 originally, and then take a log of 2, they become 1, 2, 3, 4. All right. Oh, yeah, sorry, that's a square root. That's square root. Sorry, that's a square root. But if the values are like a 1, 10, 100, 1,000, 10,000, like 1 million something, and if you take a log with a base of 10, the transform value will be 0, 1, 2, 3, 4, 5, 6. Yeah, you change the scale of your measurement, right? So visually it's like unfolding the x-axis, and I can see more details in the lower end. Before it was all squashed, so this part is all squashed, right? Very densely overlay. Now after logarithm, it's kind of unfolded. And then I can see for each of the 5 continents groups, the relationship between x, y, they all seem to be kind of linear. Linear means the trend line is kind of straight line. Okay, I can see the trend line here. I have five trend lines. The red one is for Africa, the yellow one is for America, blue one for Europe, green one for Asia, and then the little purple one is for Oceania countries. They all seem to be kind of a straight line. Okay, a little bit curved, but generally speaking, it's quite straight. Okay, kind of linear positive relationships in all these groups. Okay. Okay. All right, and then this kind of the band, the gray bands around the line, they are the kind of confidence intervals of the average. Okay, we learned that in future in the wake of regression. You can remove them if you like. Okay, I'll just leave them there for the moment. All right. So remember last week we talked about wrapping, facet wrapping. So you can have a multiple subgraphs of the groups by some categorical variable. Okay. So basically now I'm facet wrap the graph by continent. And I also request my trend line to be a straight line. Okay. So in the geometry smooth, I put a method equal to LM. LM, I think, represents linear model. Linear means straight line. Okay. So I request my trend lines to be straight lines. Okay. I don't want the curved lines anymore, smooth lines. I want straight lines. And then I facet wrapping by continent. So I have 5 continents, 5 groups. I have 5 graphs or 5 subgraphs in one graph. Okay. Yeah. Okay, let me give it a try. Let's see. Should work. Yep. Okay, so we can see more details for each continent group. So how many variables we have now in this graph? We have a x variable, y variable, color variable, size variable, and a facet wrap. But we use continent for both coloring and facet wrap, which is kind of redundant. So we can add one more variable here. Okay, we have a GDP per capita. We have a life expectancy, they are X and Y. We have a color by continent. We also facet wrap by continent. And then we size the points by population. So we use the continent twice for coloring and for facet wrapping, which is kind of a waste of information. Okay, so we're going to add one more variable. We can keep the facet wrapping by continent. We're going to use a year to color the points. Okay, so next one, I'm going to replace color by continent with color by year. Okay, color by year. So now I have 6 variables in one graph: X, Y, color, size. 5 variables: X, Y, color, size, and facet wrapping. 5 variables. Yeah. I think I made a mistake before. I said the coloring variable has to be categorical. Not really. You can also color by some numerical variable. Yeah. Like this one, year. Year is a numeric variable, numbers, and then the algorithm will color the geometry using different shades for different numerical variable values. So now we can see the relationship shape between GDP per capita and life expectancy across the 5 groups of continents. Okay. For countries of different sizes of population and they're kind of a change over the years from 1960s or 50s to the first decade of 21st century. Okay, when the points are dark, I mean the earlier years. When the points are light, they are the recent years. Okay. So you can see, generally speaking, the population level and economic level for all the countries in almost all the continents increased over those half century. Okay, and the relationship between these two variables, they all seem to be positive and linear. Okay. I also modified the look of my graph. I added a title. I labeled the X and Y variable axis properly, like the labels. Color, I call them year, size, called population, and the X variable, I call the log of GDP, PC per capita in US dollars, and the Y is life expectancy in terms of years. Okay. I also added a title. But in your report, I think you probably prefer to have a title in the caption of your graph rather than put a title in the graph. Okay. Normally we have a title without, we have a graph without title, and then below the graph we see figure 1, figure 2, full stop, relationship between blah 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 blah. Right? We call those as captions. Or table 1, sample, sample descriptive statistics. Table 2, regression coefficients. Blah blah blah. Yeah. So we call those things captions of the tables and graphs. Right? So we usually don't put title inside the graph. But I put the title up here just because I'm doing a presentation. Okay, I'm not writing a report, so I need a title. I just put the title there. Okay. All right. The last one I want to mention is normally we can also assign this graph to an object. Okay, and then next time if we want to graph, we can just call the object out rather than running the whole block of syntax. Okay. So you can see I'm going to plot my graph and assign a graph to an object called a myScatter. So after running this code, you will see another object in the global environment called a myScatter. Yes. Okay. And then if I want to graph next time, I just need to run myScatter. Get a hint here. Yeah. And if I click and run myScatter, I will get a graph. Come on. Yeah. Don't scare me. You never know. All right. Hopefully, I mean, I'm pretty sure the code today will help you help you finish your report or assignment. Because I think you will need some scatter plots in your first assignment. And then scatter plot, as I mentioned, is probably one of the most commonly used statistical visualization tool in the literature, in writing scientific papers. Presentations, like we use scatter plot a lot. Okay, any questions about scatter plot so far? About people online? Any questions about scatter plot? Okay. Shall we continue? Then we finish a bit earlier. Okay, all right. The second half of today is about the relationship between two categorical variables. Okay, so if both variables are categorical variables, and then the scatter plot doesn't help anymore. Okay, we can use a different tool called the bar charts. Okay, or cluster bar chart, strictly speaking. Okay, so this one, the first one I show here is a simple bar chart. Okay, so we just compare the frequencies of the categories of one variable using either a vertical bar chart or horizontal bar chart. The code here, again, I'm going to create a categorical variable called vals, because in my data set, the GDP, the get miner data set, we don't have enough meaningful categorical variables for us to use. Country is a categorical variable, but probably too many categories. 142 countries. I'm keeping the continent, because continent has a kind of a meaningful categorical variables, and we have 5 categories. Okay, and then I need one more categorical variable for my demonstration purpose. So I created one more variable called the vals based on the GDP level. Okay, so that's how I created that variable using the knowledge we learned in week 2 or week 3. Data wrangling, remember, using the ggplot as a ggplot, using tidyverse functions to process data or manipulate data. All right. So what I did is I'm going to use $20,000 per person per year in the GDP per capita as a threshold to classify countries into developed and developing economies. Okay, it's just a random threshold. Okay, maybe useful, maybe correct, maybe incorrect. Okay, just for teaching purpose, for demonstration in the charts here. So I'm going to create a new data frame called the GM underscore 2007, because I only want the data of those countries on those variables in the year of 2007. Okay, so my new data set is called the GM underscore 2007. It comes from getMinder, and then filter the records where year equal to double equal. That means equivalent to 2007. Okay, and then in the new data set, 2007 data set, I'm going to create a new variable called the called the vals using the mutate function. The vals is equal to this logical evaluation here. GDP per capita over 20,000. So in this logical evaluation, the results will be either true or false. If the GDP per capita of that country in 2007 is higher than 20,000, equal or higher than $20,000, the value of vals will be true. Otherwise, sorry, if it's higher than $20,000, the value will be true. Otherwise, if it's equal or less than $20,000, the value will be false. And then I use the if vals function. If it's true, it's called develop. Otherwise, developing. Okay. You can use the same trick in your assignments to create binary logic. Binary variables easily. Okay. I did that in the second class. I remember when we are playing with the Star Wars data set. Remember the Star Wars characters? We talk more about if else like a looping, decision control in a future workshop. When we are talking about the programming basics in R, we have a workshop on that. Okay. All right. So let's create this new variable. Control C. Going to run. Okay, I got a new variable. I got a new data set here. Underscore 2007. 142 observations because I have 142 countries. Only one data from that year, single year, and the 7 variables. Okay, one more variable. Why? Because I have the vals. Okay, you can double check if the GDP per capita is less than $20,000, it will be developing. If it's above, it will be developed. Okay, yeah. All right, and then you can plot these 2 single plots easily. The first one is just plotting the variable vals. Okay, and the geometry is bar. Okay, and the default bar chart direction is kind of the horizontal, vertical bars. I mean, depends on how you see. The first bar chart, the one on the top, you can call it. I think people call it the vertical bars because the directional bars are vertical. Yeah. But if you're talking about how do I arrange the bars, it's horizontally arrange it from left to right. Right. Doesn't matter. If you show the bar, people know what you mean. Okay. And if you want the bars on like a horizontal bars, if you have many countries, you have many categories, and if you put the bars vertically, the graph may be too wide, and then you can put the bars horizontally, and then your graph will be long. Okay, you may prefer that. If you want to do that, you just say y equal to vals. Yeah. Yeah. This one. Yeah, this one just say you may want to save your graph code as a object, and then in future, if you want to graph again, you don't have to run the whole block. You just have to run the object. You just request the object of the name of your graph, and then the graph hopefully will show up. Hopefully, I can't guarantee that. Okay. Yes. All right. So by changing x or y in the I6, you can change the direction of the bars. Okay. Yeah. I think by default is vertical bars. All right. Now this is the important one. So remember, what we are interested in is the relationship between continent and the vals. So we want to explore the relationship between 2 categorical variables. Okay, now we need to use cluster bar charts, not the simple ones like these two. Okay, we have 2 variables we want to explore, 2 categorical variables. One is vals, which has 2 groups, developing versus developed. The other one is continent, which has 5 groups, 5 continents. Okay, so that's the plot. ggplot. So this time I put my data frame name inside the function. That's how you do it. If you don't want to use the pipe operator, you put the data frame name in the ggplot function and then comma, and then x equal to continent, filled with vals. Don't put the vals in y, okay? Just x equal to continent and the filled with vals. You get the vertical bars of the 5 continents, and then in each bar, we have actually in each bar you have in each continent group we have 2 bars. We stack one on top of the other, okay? Because one is for the green bar and the red bar in each group, and we stack them one on top of the other. Okay, this is we call it stacked bar charts. Okay. You can see in Africa, in that year, according to the $20,000 standard, all countries were developing countries. And then in Europe, more developed economies than developing economies. And then in Africa and Asia, more developing ones than developed ones. And then in Oceania is a small continent, so smaller number of countries, and they all seem to be developed economies, right? All right. Okay. And then we can modify that. We can put the bars in each group side by side. Instead of putting one on top of the other, instead of stacking them, we can put them side by side. So we call it side by side bar charts. So how to put them side by side? You have to modify your geometry bar syntax. So we put the position equal to Dodge. Position equal to Dodge. Okay. And then also make my bars kind of translucent. So alpha equal to, I make alpha equal to 0.6. And I make the background black and white. Before it's kind of gray and there's grid lines. I just make it black and white, simple background. Okay. And then also get rid of the grid lines. The grid lines in the background. Just make it black and white, simple. Nothing extra info, no extra information in the colors. Okay, so let me try this one. It should be okay. Hopefully, get it run. Yes. Did everyone got the same thing? How about people online? Still there? Still there? My code isn't working. I mean, okay, no, I'm working. All right. Good. Yeah. Well, it's part of the learning, right? You get the error and then try again. If you can solve the problem yourself, that's perfect. If you can solve the problem with the help from your buddies, that's great. Okay. All right, so the first one we tried before is the stacked bar charts. Second one is side-by-side bar chart. And I want to introduce the last one for today's coding examples. It's called the kind of how do we call this one? Proportional stacked bar chart. And I'm not sure if my naming is 100% correct, but I think you get what I mean. So it's stacked, but I'm not plotting the frequency. I'm plotting the frequency. Sorry, I'm not plotting the frequency. I'm plotting the proportions. Pardon me, because I had only 3.5 hours sleep last night. And I'm driving today too. All right, so the difference between this one and the first one is I'm plotting the proportions this time. So for each group, the proportion is always 100%, 100%, 100%, or 1, 1, 1, 1. Okay. But the split between the two categories, developed and developing, is different. Okay. I think I probably will use this one in my presentation, depending on your audience, depending on the story you are crafting. Okay, so this one kind of giving a more impressive message to my audience. So you can see in the African, all green, in the Oceania, all red, and that's kind of a, I don't know, gradual change or jump from group to group. It's just by accident because the horizontal. I mean, so this sequence from left to right is Africa, America, Asia, European, Oceania. I didn't order the categories specifically. It's automatically ordered by the algorithm according to the alphabetic order. If you want to modify the order of the bars from left to right, you have to modify the levels of the vector variable of continent. I think continent is a vector variable. I'm pretty sure. So if I go back to my code, how to check the variable type? Remember, use class, and then gm underscore data set name, and then dollar symbol, and then variable name. Okay, it's a vector variable. So vector variable, the categories are ordered. If it's the names by default will be ordered by the names of categories alphabetically. If you want to change the orders, you have to change the levels of the vector variable manually. We have an example in the wake of data wrangling using the ggplot tidyverse function. I always say ggplot. So if you forget how to modify the levels of a vector variable, go to that wake. Okay, probably wake 3 or wake 3, I think. Vector variable changing the levels. Yeah. So this one just accidentally we have this kind of stepping graph, like staircases. Interesting. Again, I also modify the labels, the title. Okay, and also make this graph as an object of my bars. In case I want to use a filter, I don't have to run the whole block of code. I just run this my bars, this single line my bars, and then this bar chart will pop out. Hopefully. Okay. Any questions about the bar charts? Or I should say clustered bar charts. So there are the three basic ways to cluster bar charts. Stack them, put them side by side in each group, or plot the proportions in each group. All right, and then a few words about the general advice about graphing or data visualization. One of the concepts is called the data ink ratio. I mentioned last week. This time I have a slide here. So data ink ratio is a concept proposed by Professor Tafti from the Netherlands, I think, and he has a very influential book in the area of data visualization. It's called the Visual Display of Quantitative Information. It has 2 editions. You can borrow a copy from library. I think we have the copy, or maybe a PD digital copy. So one concept is called the data ink ratio. That's the ink you use for data divided by the total amount of ink in the whole graph. And then Tafti said we normally prefer the graph with a higher data ink ratio, or we prefer a graph with a lower proportion of noise ink in there. So these 2 graphs, you see the one in the back, colorful bars, colorful backgrounds. I don't know what the color represents, the brown color, and then unnecessary gray background, and also horizontal grid lines. So lots of noise ink in the before graph. Okay, if we apply the principle of data ink ratio, we probably should redesign the graph to remove the unnecessary ink used for the things you don't want to, you don't really care. The background color, the green lines, title, whatever, and then just use the ink for the data you want to present to your audience. Okay, it's kind of design philosophy. You may or may not follow it. You may just prefer the busy one. Who knows? Yeah, okay. But this is a concept I think you may have an interest in, or I think people should know. And then the second one I want to the last slide today, okay, is the one I mentioned last time. So why do we need data visualization? We learned summary statistics like a median mode, correlation coefficient, quartiles, blah, blah, blah. Can we just report the numbers instead of showing data? The summary statistics only summarize data. They don't tell you the full story. Okay, data visualization, the graphs can tell more information. So the one on the left, you can see we have a 1, 2, 3, 4, 13 data sets. Okay, 3 rows and a dinosaur one. We have 13 data sets, and if you scatter plot them, they look different. So there are different data sets, different relationships, right? The dinosaur relationship, the circle relationship, or the star-shaped relationships. Okay, or no relationship, like this one, first one, no relationships, or X factor. Okay, so they have different relationships, but if you just calculate the summary statistics, they are almost the same up to the second decimal. The average of X, average of Y, the standard deviations, and even the correlation coefficients of all the 13 graphs, they're all about 0.08 negative. Okay, so if you just look at the summary statistics, you may think of the same thing, but there are 13 different things, different patterns, different relationships. Okay, and the one on the left, on the right, the box plots is basically a visualization of the minimum, maximum, and then Q1, Q2, and Q3. So box plot is just a visual of the summary statistics. So box plot doesn't really show all the details. If you see that we have a B, C, D, E, F, G, 7 different data sets, the distribution of the variable is different according to this density plots or something, bubble plots. But if you just plot the box plots, they're all the same, exactly the same. They have the same minimum, same maximum, same Q1, Q2, and Q3. Yeah, but if you use histogram or density plots or violin plots, you will see a bit more details. Okay, so the importance of data visualization is that it can tell you a more complete picture of the data than the summary statistics. Okay, all right, that's all for today. Please log attendance when you have time, and also give me some feedback. I will email all the links in the afternoon. The links to the attendance form, feedback form, a link to download the slides, which we have done already, and also a link to the recording for today's workshop. Okay, just the first few minutes are a lot, but I think we got the important information recorded. Okay, any question? Feel free to ask me. I'm going to stop the recording. Stop recording. Oh. There you go.